Welcome, everybody, to Cloud Innovator Tech Talks for Telecommunications. I'm Brian Krasik, Head of Telecommunications Industry Marketing here at Google Cloud. And we're going to be talking about cloud native 5G core and RAN. Oh, yes, it's a topic that you know and love and people want to hear about. So the networks are going to the cloud, and I have with me today Roberto Company. He's our principal analyst at Omdia Research. Roberto, welcome to the show.
Great. Thank you, Brian. Nice to be here.
You know what? This is a topic that's really interesting to people, and it's quite a change in tradition of how we've normally designed and engineered and operated our networks. So I'm really happy that you could join us. And I want to kind of just dig right in. And what are some of the drivers on the network side and this cloudification of networks, this virtualization? What are you seeing in the marketplace?
Yeah, that's a really good question, Brian. So, from the beginning of the 4G era, we started to see mobile data traffic growing on a year-by-year basis. And this means that obviously network operators or mobile operators have had to continuously improve their network capacity. But this was very challenging because on the one hand, they had to continuously invest in the networks, but on the other hand, there were the financial challenges and sort of flat ARPU, so average revenue per user, which has been kind of flat and declining for some years now. So, in our business as analysts, we do operator surveys on a continuous basis, and that's where we go to senior leadership or network designers, network engineers, and ask them what is it that's keeping them up at night, and what are their concerns in terms of the technology and what they're seeing in the market. And this informs our research. So in this particular case, we know that they've had to go through this complete mindset change and look at the best practices from other industries, such as the IT industry, in order to improve their network efficiencies, lower cost, what we call the total cost of ownership, and really move along from building purpose-built hardware equipment to what we call virtualization or softwareization. And that really means disaggregating the network, bringing out network functions, separating those from the underlying purpose-built, usually proprietary hardware, and run those on generic servers. And that's really where the gains in economies will be to become more like cloud providers.
So that's really interesting. I have to be honest with you. We've been talking about cloud networks for 10 years or so. So what's changed and why now?
Mhm. So in terms of network capacity, what's really changed is that operators really can't afford to spend all the time to provision new equipment. So when they need to add capacity to their mobile network, they need to add boxes basically to add those and add the capacity. And that requires not only a lot of time consuming resources, but also specialized telecom skill sets. And bringing some of those boxes up would mean weeks or if not months of configurations and integration. And that's really what's changed in the mobile domain these days.
So they're really searching for really more efficiency from an operational perspective as well.
Yes, that's correct. So they want to not only reduce their capex cost, but also to reduce their opex cost. But that's quite a bit of a challenge. I mean, over the last, I would say the last 5 years, mobile operators have gone through this virtualization journey where they started with virtualizing the packet core, the core network, because that's, I mean, I wouldn't say that's simpler, but it's a bit easier than the radio access network, the RAN, and we'll discuss that a little bit more, I'm sure. But the RAN is very, very complicated. So the core they've been trying to, and many operators now have what they call virtualized packet core or VEPCs, virtualized evolved packet cores, where they have those softwares, the network functions running as virtual machines, what we call as virtual network functions on hardware, on generic hardware or servers.
So you talked about the proprietary nature and how we've done things in the past and just moving boxes and so on and so forth. It's not just a lift and shift though. There's some rewrites that have to happen, and there's a lot of synergies across the marketplace. So, what are
Yeah.
some of the challenges that are coming up as a result of this migration and this push towards cloud-based and cloud-native networks?
Yeah. In terms of some of the challenges is really how to integrate some of those VNFs. So the idea is to integrate those VNFs onto the hardware. So white label hardware or different multi-vendor hardware. And that requires some integration work that needs to be done. So it's not that as it's completely simple, but it does create some efficiencies when you can integrate those VNFs and cloudify some of those, and then actually you bring in some of those economies of scales that we mentioned earlier, and to be able to reduce your not only your capex but your opex. But then there is the good news is that we're migrating from virtual machines to cloud native platforms, and that also brings new agilities in order to by using containers and microservices that 5G will really depend on. I mean, 5G core really significantly depends on improved agility compared to the previous generations in order to scale up and scale down those services that's required.
And I think that's a really important piece as you scale up and scale down, and you look to kind of the edges of the network as well.
Yeah.
You spoke a little bit about multi-vendor, right? Multi-vendor architectures. I think that's really critical. I think of the old days when I was designing wireless networks. We divide the US in half. Here's the Mississippi. Everything to the east is vendor A, everything to the west is vendor B for core and RAN. And that's how we would run it. You don't want to be dependent on just one vendor. Is that still the design approach? And how do hyperscalers play into this?
Yeah, so that's a very good question, an interesting question. So you're right. In the traditional way of building networks, it's been the handful of vendors that have dominated the telecom industry, both the core network and the RAN. And that's really because they have produced over the last several decades full stacks of both of those domains, the RAN and the core. Now, when we add in disaggregation of the software, when we add in virtualization, we're really opening the door to multi-vendor. So operators will now have the opportunity to buy their specific VNFs from different vendors, not their traditional legacy incumbents, but now new players are coming onto the market where, best of breed can actually work. And this creates not only competition in the industry, which is great, but it also creates innovation in the industry.
And where do you think we are in this kind of environment where you can switch in and out VNFs and vendors? And we've traditionally seen people take an open source and take their own view of open source, and it would start to lock people in because it was their view of open source.
Yeah.
Is what we're going to do now with cloud different?
So it depends a little bit on the domain. So in the core network, as I was mentioning before, it's a little bit simpler because it's possible to integrate those VNFs and CNFs or container network functions onto the platforms. But when we want to have multi-vendor in the RAN domain, that's a little bit more challenging, and it's still a bit of a work in progress. There has been significant amount of work already done over the last 4 or 5 years. For example, industry initiatives such as O-RAN Alliance has helped define some what we call open interfaces, which are necessary in the RAN, because you really have to bear in mind that the RAN, contrary to the core, it has 3 network layers. And I'll go into a bit more detail about those later, but just to bear in mind that in order for different vendors to communicate between those different layers, so vendor A product can work with vendor B product, those interfaces have to be open. We can no longer do things as used to be done before, where you had, like I was mentioning before, a full stack from a single vendor, and there, of course, the interface was vendor locked, so there was no need to actually open those vendors because both sides of the the stack was from the same vendor.
So I think let's just jump into it now. So we're opening up the stack, multiple vendors. We're going cloud native. What's more advanced, kind of the core deployments or the RAN? What are
Yeah,
you seeing in the market?
yeah. Okay, so let me bring out one of the slides which I have. So on this slide, we have, if we look at, I think it's also important to bear in mind some definitions because if you see on this slide, we're looking at the RAN and the different migration paths of the RAN. But over the last few years in the industry, we've seen different nomenclatures and different definitions, such as Cloud RAN, C-RAN, vRAN. But for us at Omdia, we look at it from a open virtualized RAN, which is open vRAN really. And if we look at this diagram here on the left, we can see the traditional, the legacy RAN, the way it was built, where you had at the tower the radio and the antennas, and then at the bottom you had the baseband unit. Now, moving along a little bit to the middle infographics, you can see that we're actually beginning to separate the baseband unit into its principal components, which is the centralized unit, the CU, and the distributed unit, the DU. And those can be separated from them, so no longer have to be placed at the site. The CU in this case is actually being virtualized and being placed at a data center, for example. And this creates the economies of scale that we mentioned that operators are looking for. The distributed unit, the DU, is still a proprietary hardware which usually sits still at the baseband of the base of the tower. Now, moving just along to the next diagram here on the most right, you can see we're actually virtualizing the DU as well. Now, I mentioned the DU is a bit more complex to virtualize, and the industry is working on this. This is a work in progress. Really because, so I mentioned before that the RAN has 3 layers, and we can see this on the chart on the boxes here on the right. The DU takes care of what we call layers 1 and 2, and those are they are most compute intensive. Particularly layer 1 is very compute intensive, and it has certain real-time functions that need to be executed. Now, traditionally, obviously, this has always been done in generic hardware using x86s, and they can be done. I mean, there are some operators that are using x86s to do that. But when we start looking at 5G use cases and massive MIMO antennas, x86s become a bit less efficient, and not only in terms of power usage, but also you would need more and more servers to carry out. Because remember, massive MIMOs will be looking across 100 megahertz, traditionally about 100 megahertz of bandwidth, and that's a lot of mobile data throughput. So on the
It's
next,
a lot of data. It's a lot of data. It's a lot of real time, and that's going to be happening out at those edges as well, right?
yes, that's correct. So if we look at this other next slide, we're looking at how we can actually split and understand, because so there are different ways of breaking the network and where we can place the CU and the DU at different positions. But what's really important to bear in mind is that there are trade-offs. So operators really need to think about how they want to architect their network in terms of what use cases they want to run. So if we look at option 2, which is the leftmost architecture, that we're placing both the CU and the DU at the baseband, at the base station. So there's
Yeah.
really very little front haul. And this is what I was coming to before, that it is quite complex, it is very compute intensive, and that's just one of the options. But as you can see, it's just one of the options. If we look at the last most diagram, which is the option 8, we are now creating an architecture where we're moving both layers 1 and 2 away from the site. Now, the challenge with that is that the front haul that we have over here, that's going to be requiring a very, very important amount of data that's going to go through. Now, this is not mobile broad. So let me be specific. This is not mobile data, but this is front haul traffic, which is happening between layer one and the radios at the site. So it's really important for operators to see what kind of architecture they want to do and what hardwares they have at the site and what fiber they have. Because um, if you remember, some operators can deploy this option 8. I'm sorry, yes, option 8, but not all of them. If there is no fiber, there's no point in deploying this. So we need to look at option 7.2, which is the middle one. This is the sweet spot for 5G. And this is what ORAN Alliance has been working towards in terms of deploying. So what we're doing here is we're splitting the DU into a lower layer DU, lower layer 1 and upper layer 1. Um, so that some parts of the DU actually sits at the site and some of it is centralized. So in this way, we're getting both the efficiency of centralization and we're depending less on that front haul traffic. So if there's less fiber availability, that can actually work as well.
It's really fascinating when you see the evolution of the network, both core and RAN. And I think that's a really nice explanation and breaking it down by layers and by options and opportunities. And as you mentioned, sometimes use cases are going to drive how you deploy. And we're seeing a lot of pickup in private 5G and campus environments. What are you seeing in the marketplace around those types of networks?
Yeah, so we, in terms of Open RAN, at least, we're looking at in this chart that I have, looking at first use cases being more around rural and private networks or at venues, and this is really because, as I saying, Open RAN is still a work in progress. There is some maturity, but there's still some work left to be done. Um, in terms of acceleration of the layer one, what we were talking about just now, it's important activity which is still ongoing. So what operators and those vendor partners they're doing, they're trialing in some of these less complex scenarios, such as rurals or private enterprises or venues. That's because one, there's less spectrum bands to worry about, less carrier aggregation to be done, and two, they can do this using not just 5G but also 4G, where because the traffic is much less in rural compared to dense urban, uh, we don't need to depend on those massive MIMO antennas and bring in some of those complexities. But then, as the products become more mature, we're looking at actually deployments into more dense urban or nationwide even.
So, Roberto, what about you were talking about the rule now from a private 5G perspective, and or what's the coverage model? Why do they need that in the rule from a private 5G perspective? Is it more of a manufacturer? Is it some type of remote operation,
Yeah,
or is it
I
just
think it's
plain old coverage?
a bit of a mix of everything. I think it can be different scenarios, different use cases in different scenarios. So, if we look at some of the industry use cases and enterprise use cases, for example, such as ports, transport ports where ships come in, those are outdoor environments that perhaps it's a bit of a more of a private network where the operator is not the public operator, mobile network operator, but it's actually the port operator that deploys these private networks, and they want to deploy, edge computing, some sort of coverage to control some of the cranes. So they really need that coverage, but they also require some security. Now, in terms of other enterprises and venues, for example, those can be different use cases where it's more in terms of mobile broadband. So in a sports stadium, for example, you want your customers to be able to access Facebook and upload a lot of videos and pictures on an ongoing basis. So that's really coverage and its capacity.
I mean, in stadiums, I just want to order a beer, but hey, I'll do it over 5G. I'll do it over Wi-Fi. It doesn't matter. But let's move on. So I think let's kind of wrap things up. One of the things that I'm seeing across the industry is a real buzz around orchestration. When I talk to my friends at Ericsson, Nokia, and other large NEPs, they're like, "Hey, I have a ton of orchestration engines." So, what's happening from your perspective, and what are you seeing? Because there's many layers of orchestration that need to happen as we decompose that more monolithic approach. Correct?
Yes, that's right. And I think that's a really interesting topic because traditionally every vendor has produced its own orchestration system. Now, as we're moving to this multi-vendor environment, it's becoming more and more complex because then operators will need to have an orchestrator per virtual network function, per vendor. And then it's not just about the RAN, but you also need to have orchestrator for the core, an orchestrator for the transport network. So the three domains, there'll be multiple orchestrators as things stand today. Now, the idea would be to simplify this, and there's a lot of activity work being done currently to be able to bring a single system that orchestrates across all the domains and across multiple vendors. But I think, again, this is a bit of a work in progress.
Well, and to that point, I'll give a shout out to the Linux Foundation and Nephew, which is one of the projects that we're sponsoring. And we have a large degree of support from both vendors and the CSPs. So I think there'll be some really interesting things coming out of that as we go. Now, from a final thought, if you had to give it a grade, cloudification of networks, core, and RAN, and the efforts that you're seeing, where
I
would that
think
grade be? Where are we at?
definitely the core network is a lot more ahead because of some of the easier way of executing that. We're already moving towards the cloud native core. The cloudification of the RAN is a bit slower. It is happening. The incumbent vendors have cloud products and they're working with their operator partners, and new vendors are also very much into that. But it's still, I mean, we do our forecasts and we look at how much open VRAN, the definition I referred to before, will the spending by operators be by 2026, and we forecast about 12-13% of operator spending of the RAN spending will be on open VRAN by 2026. So not insignificant, but there is still some way to go.
That actually, I'm going to go the opposite. That seems significant, and it seems like we are
Yeah,
moving fast. This is not telco speed anymore,
absolutely.
and we're really picking up. Roberto, hey, I want to thank you for sharing all your insights on delivering cloud native 5G core and RAN.
Thanks so much for having me, Brian.
Thank you so much.